This is T here, just doing a quick video on logarithms on the calculator and using the change of base formula. So the reason for this video is sometimes when you're using logarithms, and especially when you're graphing them, which we finished the topic off on, we want to evaluate logarithms with a calculator. But unfortunately at this level, not everyone's going to have a graphics calculator, and you'll only be required to have one if you're taking maths methods later on. Or, the year 12 maths, basically. So as a result, people will have a wide range of different calculators that handle the logarithmic functions very differently to each other. And this is also important because most scientific calculators only have a log button. Like what you'll see here. This, just a log button. Just a log button. Your handheld calculators that exist in real life, you just see a log button. So if it's a log button, that means it's just in base 10. So if we have to handle other bases, we need a different way of dealing with the logarithmic function because we only have a base 10 button. So essentially the point of this video is to go through a range of different ways you're going to handle the log functions that I'm going to encounter at this particular school, so that I cover all bases, basically. So the first I'm going to cover is the best case scenario, which is the graphics calculator, because it allows you to define the log base. But this is only most likely if you're going into senior school and you buy one. So in senior school, you'll be required to have a graphics calculator, and these all have a function that allows you to enter a logarithm with a particular base and evaluate it. So the calculators we use at this particular school are Texas Instruments graphics calculators. And to access the function, I press the math button. I scroll down, past the numbers to letter A for log base, and press enter. And as you can see on the calculator, it wants the base. So you will see log with a small subscript box there, and then a normal size box there. The subscript box is obviously going to be the logarithm base, and the normal size box is going to be for the number of interest. So if I wanted to evaluate log in base 2 of 5, I just enter that, and you're going to get 2.3219205. How many decimal points is that? It's 29 dp. Okay? So that's that. That's the first answer. Now, the next thing I wanted to show you is using the Apple calculator. Now, why is it useful to show this? Because it's very ubiquitous. A lot of you have an Apple iOS device, like a phone, or you've got a laptop, which has the same calculator there. Yeah, Apple devices are so widespread, it's useful to understand how their calculators work. Now, the only confusing aspect with the Apple calculator is you often have to enter the inputs in a really weird order because the Apple calculator applies the function to whatever you entered first. So I'm going to show you specifically for logs, but that rule that they do it in a weird order applies to many of these functions here. So what I'm going to show you is the calculator from scratch. If you are using your phone, you would only see this half of it, okay? And the way that you access the full calculator is by turning it on its side. So the first step you need to do is to access the full calculator. I get that straight away because I'm using the macOS device. If you had your phone, you have to turn it to the side and you'll see all of this open up. Now what you do is press the second button to access the advanced functions, and you'll see this button here, log base y. The log base y button is the button used for logarithms with a certain base, but you have to enter the information in a weird order. You have to enter the number of interest first, so the full size number, then you press the log y button, and then you enter the base number. So if I wanted to evaluate log in base 2 of 5, I have to go 5, log y button, base of 2 equals, and then you see the same answer that we got before, actually less rounding. 321922809. I'll round that to 9 decimal points as well, just for the point of showing that it's all the same. We're getting the same answer. won't match the text. I'm just showing that it's the same answer. Okay, last and most likely what you're going to encounter is a scientific calculator situation where you cannot define the log base and you only have the log button. So I've got Desmos here, only the log button. Heck, this is the starting scenario of I have to go to functions and it's still only got log here. If I go to the Google calculator, I've still only got the log button here. So we're assuming base 10. So most scientific calculators only have that log button, so it's in base 10. But that doesn't stop us from working out the other log bases. We just need to use the change of base formula, and that is this. Log in base B of the number of interest A is equal to log in base X of A divided by log in base X of B. The order is important, so the base number 1 goes on the bottom, the number of interest goes on the top. In this formula, B is the base of the logarithm we're trying to evaluate. A is the number of interest of the logarithm we're trying to evaluate. And X, the reason why this helps us is X is any logarithm base you like, including log base 10, which we always have a button for. So using this, we can evaluate any logarithm with any base and number of interest using any calculator, even if it only has log button for base 10. So, using that formula, I've been evaluating log in base 2 of 5 over and over again, so I'm going to do the same thing. Log in base 2 of 5 is equivalent to log of any base of 5 divided by log of that same base of 2. If I put that in the calculator, so I'll do it with Desmos first, log main 5 is a number 0.69, I have to do the working out here, 0.698 etc. divided by, go back to the functions, log of 2, finish the bracket, 2.321 etc. the same as what we found previously. That's to 9 dp. I'll also show you with a Google calculator. And so your handheld scientific calculators are going to work very similarly to this. So I'd go, if I wanted to evaluate log in base 2 of 5, then I'd go log 5, the answer, divided by log 2, the answer, 2.321928095, once again to 9dp. So hopefully that's shown you how you can use 3 different types of calculator to evaluate logs of different bases. I just want to finish off with a harder example because you're going to be doing something similar to this in the graphing logarithmic graphs section. Then I'll show it using the scientific calculators because that's what you're most likely to have access to. So if I wanted to find 0.5 log of base 5 of 2, let's find the answer of that first. So the easiest people that will handle this would be people with a graphics calculator. Log base 5 of 2, that is the answer we should get. Should get 0.2133879 to 9dp. 215338279. That's what we should get. Now, let's do the calculations on the most basic one. So, if I want log 5.2, now the key here is that you need to use bed mass. So I'm going to leave the 0.5 alone for now. I'm going to work out what log in base 5 of 2 is, which is going to be log of the number of interest divided by log of the base. So 0.5 times by, now I can use my calculator to do this because it's got log of base 10, log 2, nope, log 2, oh god, jeez, clear it all out, log 2 is a number divided by log 5 is that 0.43067655807. I've got that number, and then I'm going to times it by 0.5. So I also get 0.215338279 to 9 decimal points. Now, why do I leave the 0.5? Well, remember that logarithms are very much involved with exponents, so you should treat the logs like exponents and do them first before you do the multiplication. So I dealt with the log in base 5 of 2 first, evaluated it using the calculator, using the change of base formula, and then I multiplied it by 0.5 to get the exact same answer that I got on the graphics calculator. So that should help you out with using any type of calculator for evaluating logarithms. Hopefully that helps, and I'll see you in the next video.